Hello YouTube. I thought I'd do a video about my compressors. So this is what I call compressor 1 and compressor 2. So we'll start with compressor 2 here. This is a 2 horsepower ball door electric motor. The mounts that it is on are fabricated. I made them myself, so you can use these screws here to loosen and tighten the belt. So, and there's slides on there that it fits into. So the compressor itself is a 2-cylinder single stage that is good for 15 CFM when you run it at about 1400 RPMs. Now I only run it at about 1330 when it's under a load or so. So I'm just going to focus on the air delivery here rather than the electrical part of it, and go from there. But now the way this works is when the compressor is running, the air comes out of here, goes through and up into this aftercooler. Now that aftercooler is a Durali aftercooler that I got from Amazon, tested to 300 psi, and it works pretty good. So the hot air comes out of the compressor after it's been compressed, and it gets cooled through this. There's a fair amount of air that gets drawn by the flywheel, plus I have these box fans set up, and the box fan is just a cheap way to try and move more air. So it comes out of the aftercooler, goes through here. Now this is a gauge to show the pressure coming out of the compressor. Now this was probably a mistake. I probably shouldn't have done this. The problem here is it really fluctuates because of the pulsations coming out of the compressor. It kind of gives you an idea of where you're at, but as soon as the compressor shuts off, it goes right back down to zero because it releases the pressure in the line. So now that line goes around and comes over here, and here we have a check valve. So the air pressure goes in and it goes into this system here, which we'll get to in a minute. This is compressor number 1. This is a 5-horse motor. It's a WEG motor, or WEG. I run this compressor roughly at about 950 RPM, and this is a 2-stage 3-cylinder compressor. So air is brought in and compressed through these 2 filters, which compresses them, and then the air gets compressed a second time through this 3rd cylinder here. This compressor is good to 175 psi. I only run it to 150. This one over here, compressor number 2, is good to I think 140, and I only run it to 130. So compressor number 1 has the same setup. The air comes out of the compressor, it goes through an aftercooler, and after the aftercooler it goes into piping. It comes around here, goes through a check valve, and goes into this system. Now this system here is a bunch of cooling pipes basically. So the air comes in, it goes upwards, which you want it to go upwards. The thought here is to have the moisture go down. So the air goes up, the moisture drops out, goes up and over and back down, and then it does that 5 times throughout this setup. So the idea is that any moisture that comes out of these 2 compressors gets caught in these drain valves. And then you can just open them up and release the water. So it goes through that manifold. There's another system gauge. This gauge actually is pretty pretty reliable. It's not, it doesn't jump around a whole lot because it's way past the compressors. So the air comes down, and I put stickers on there to show the airflow direction. But the air comes down, and it comes out right here. It comes up and goes into filters. Now this is a particulate filter, this is an oil filter, and this is a desiccant filter. This desiccant filter, the problem with this is that it catches too much moisture way too fast. I put blue desiccant beads in there, and within maybe 15 minutes or so, maybe a little bit longer, they start to turn pink. I probably should just take them out of there and not use it. So they come out of that filter, and they come over here to a larger desiccant filter, much larger filter. This filter is good for 30 CFM. Between the two of these compressors, I should be getting about 15 out of each. So this is 30 CFM. It goes up, and if you notice throughout the video, I try and force the air to go upwards, because if you force your air to go up, the moisture tends to drop out of suspension and go down, and I have drains set up so that I can drain it out. So the air goes upwards, comes across here, and now it goes into the tank. So these compressors don't pump air directly into the tanks, because if they did, the tanks would fill up with water. Then you end up with issues with the tanks possibly rotting out. And these two tanks that I have, actually all three of them, have some time on them. They've been used, and I like to keep as much moisture out of them as possible. So this first tank here that the compressor is mounted on, I believe is a 40 or 50 gallon tank, and then I have that mounted here on top of I think it's an 80 gallon tank. It could be 120, but I'm not 100% sure on that. So the air comes out of the compressors, it goes through the aftercooler, it goes through my manifold setup, it goes through my desiccant dryer, and after that it goes into my tanks, which store the air. So the air gets stored in the tanks. This tank here is connected to the tank below it, and I try to use flare fittings so that I can take things apart and repair them if needed. Haven't had to so far, but you never know. I hate to solder things together and then have to fix it later. So it comes across here, goes into the bottom tank, and then from the bottom tank I have a valve right here with some brass fittings and some braided line that goes up to another particulate filter. This should catch any dirt that comes out of the tanks since they're used, and goes up into my system. So now as far as my piping is concerned, most everything is copper, brass, or stainless. I tried not to use steel, or tried to use steel as little as possible, because when you have moisture going through there, it tends to want to rust. So this is the drain for the top tank here, which is tied into the manifold drains. So now compressor number 1 here, same setup. It pumps into the same manifold, goes through that manifold, through that filter, through the desiccant filter, and it comes down and goes into an 80 gallon tank here, also with a check valve so that the tank can't bleed back. So that's the setup there. And then it comes out of the tank up here, comes out just like the other one into a particulate filter, and goes up into the rest of my system. So now both compressors have this valve right here, and what this valve does is this valve is set you can change the settings, which I have it set that once it comes up to almost the highest pressure, if you want it to run continuously, once it gets the pressure, it'll stop running, or I'm sorry, it'll stop compressing air and it'll just run idle. You can turn this on and that will send the air pressure up through to the cylinder head of these compressors. And what that'll do is that will make the compressor run idle until it's called for again to compress air and make more pressure. Both of them have this. The other compressor here has its own setup also. And in order to put it into continuous run mode, all you have to do is turn on that valve, and you heard the cylinder heads accept the air pressure. So I'm not going to get too much into the electrical, because these switches determine which lights are lit as far as whether or not it is running in compressing air or running in idle. This is also the motor starter, but I was thinking I'll do another video as far as the electrical goes. This compressor has its own setup also. And again, I have check valves going into the tanks so that they can't bleed back and lose air pressure through this system. There's a check valve here going into this tank. And I have a T right there that feeds my on-off switch. So this is a totally homemade system. You know, I didn't buy one from Tractor Supply or anything like that, because this compressor right here, if you run it at 1400 RPMs, is good to 15 CFM. So I run it at 1400, 1350, give or take. So I'm figuring I'm probably getting close to that 15 CFM. I don't want to run it to its max, because now you're just taking life off of it. It's good to, you can use up to a 5-horse motor on it. I'm using this 2-horse because I had it, and it was expensive, and I didn't want to waste it. So I figured I'd put it on there. I sized my pulleys correctly to get my correct RPM. And you OSHA guys are going to say, oh, there's no guard around it. Well, too bad. So this compressor over here, compressor number 1, you can run a bigger motor on this one, but the 5-horse, as far as price and everything is concerned, runs it pretty good. And I think maximum pressure, maximum RPM for this compressor, I believe, is 1,000, and I run it right around 950. Again, not trying to push it to its max. Like to get some life out of these. These compressors do have hour meters on them. We're at 21 on compressor 2. We're at 25 or so on compressor 1. I try to keep them even. And this little guy over here, since it's a 2 horsepower, when I'm running die grinders and small things, this is the one that I try to run. I had an issue here with the belt being too long and it was causing too much vibration, so now I've shortened the belt, and we'll try and get those hours up to match. So, but that's pretty much my setup. This filter right here works really well. It has a little sight glass on the bottom of it, so you can see when it turns pink instead of blue, it's time to change the desiccant. Within the between the 2 compressors, I have about 46 hours. I've only had to change the desiccant once. So, and this thing is capable of moving, I believe, 30 CFM. I figure these 2 compressors are probably putting out maybe just under 30. So, the reason I put the continuous run valves on them is because I want to use these eventually to run together to run a soda blaster. So they may not be enough. I do have another compressor that's going to get tied into this system, which should put me roughly at about 70 CFMs, give or take. But that's pretty much my setup. Like I said, the water is meant to collect in these manifolds. And these valves down here, you can just open them up and let the water out, because I'm sure there's some in there now. There it goes. That was the first valve. There's probably some. What I found is I have 5 of these valves as far as these manifolds go. What I found is the first 3 tend to collect water. The second 2 back here, usually there's not much of a problem with moisture. This valve right here is the feed going into number 1's 80-gallon tank, and I almost never get any water out of there. The tank does have a drain valve on the bottom of it, as does this one. It's just too hard to bend down there and show you, but this is the drain valve for the top one, the little guy. So that's pretty much my setup. This is the pressure relief that goes to my air compressor switch that relieves the pressure. It relieves the pressure from the compressor here through the intercooler, this line here, and up to this check valve. There's a pressure relief on compressor number 1 also, which also goes to the compressor switch. And I have a gauge set up to it to see how much pressure is in the tank. Compressor number 2 also has a gauge to tell you what is actually in the tank. Since there's a check valve here, the tanks won't bleed down. So, and I used Teflon tape, the yellow gas rated Teflon tape. I don't really have any problems with the tanks bleeding down. I do have an issue with the manifold here bleeding down. If you leave it sit for a day or 2, it'll go down to 0. You can see the gauge right now is probably what, about 140 or so, give or take, 120. That will bleed down, but we're good to go here. And there is a valve that shuts the tank off so it doesn't feed out into the rest of the system, because the rest of the system does have leaks that I haven't found yet, but the tanks pretty much stay full. This tank has a valve also, so when you want to use the system, turn that on, it'll fill the tank. It'll fill the rest of the system actually. So, but the tanks for the most part stay full. If you leave them sit for quite a while, they will lose pressure, but there's no hissing noises like major leaks. My manifold back here, the reason I think it loses pressure is because to save money I use the cheap water valves. So, which is no big deal, because that little bit of copper line doesn't take a whole lot to fill back up, so I wasn't super worried about it. I put that gauge in there, and then this gauge here was an afterthought to show where the system is. Plus this had to be plugged, and I figured, I had an extra gauge, we'll just put it in. So there we go. There's 2 gauges. They're water-filled gauges, so they're pretty accurate. They don't bounce around. Plus they're far enough away from the compressor that they shouldn't bounce around. These little gauges here, the reason I have them there is to see what the compressor itself is actually putting out. They do jump quite a bit, but as the compressor puts out more and more pressure, they do go up. So if I had an issue where, let's say this line would crack and this compressor wasn't putting out any more pressure, this gauge here would only go so high and we would know we would have a leak. So it kind of helps you. This is my monitoring station, I guess you want to call it. I'll get more into that when I do a video on how I did the electrical. So, but that's my setup. This is 2 of my compressors. Like I said, I have a third one that I'm going to add in that makes 38 CFM. It's a 10 horse 4-cylinder. I just haven't added it in yet, but works pretty good. Like I said, I haven't started soda blasting yet, but when I do, we should be hopefully good to go. And I put the, like I said, I said earlier, I put the box fans in just to help to move some air. They were cheap. I don't know, what do they cost? 20 bucks a piece. So they're in. And if you want to turn them on, all you got to do, hit that switch. Your tachometers turn on, your fans turn on, and you're ready to switch on your compressors. So all right, well, hey, thanks for watching. If you have any questions, ask in the comments. I'll do my best to answer. As far as parts and everything goes, like I said, I'll try and help you out as best I can. Like I said, this setup works pretty good for me so far. As far as die grinders and you know, tools that use a lot of air, these two compressors keep up great. Now, when I start getting into a soda blaster, now we need a lot more CFM, and that's when the third compressor is going to have to be added into the system. So, but it's basically my setup. Like I said, it's all homemade. The compressors, both compressors came from compressorsource.com. So did the switches and the gauges and different things like that. This motor here came from Amazon. The 2-horse motor that I bought that years ago to try and fix another compressor that I had that I ended up abandoning. Like I said earlier, I had it. I didn't want to waste it. I didn't want to try and sell it. I thought, well, we're going to use it and see how it runs. It does actually work pretty good, so I can't complain. I have a light set up here. Oh, I gotta turn on the switch. That helps to light the area if you have to do any work to it. If you have to change filters, whatnot. So, and like I said, I'll probably do a second video as far as the electrical goes. The tachometers, the lights, the hour meters, and things like that. How I wired them in. They both have 5-horse motor starters, so on and so forth. We'll go through that. So, all right. Thanks for watching.